Hi, everybody. So today I just wanted to review everything that we've learned so far about diffusion. I wanted to use some of the examples that you gave me in your project to put some more specific words to what you guys have come up with. So today we're going to talk about diffusion. We're going to take it a step further and talk about different types of diffusion. But what I want you to bear in mind as we do this is that you already know what you need to know about it, okay? So here's just a quick little video to get you guys feeling good. This is my nephew, Erwin. He's about 10 months old, and he found himself in a mirror today. He's so cute. Oh my gosh, I can't get enough of that. Anyway, just wanted to share that with you. It made me smile today, so something for you. Okay, so diffusion. This is, as you know, the movement of particles from an area of high concentration to an area of low concentration. So, this is basically what we call simple diffusion. This is things spreading out. And this was Lily's example, Liliana's example. Before diffusion, we have the particles are really close together, high concentration, and here they are spreading out. So really simple. And because it's really simple, we call it simple diffusion. Okay. Now, obviously, when we're talking about diffusion in a cell, it has to get into the cell somehow. And in order to do that, it passes through a membrane. As a reminder, a membrane is just something that separates one area from another. And in this case, we're talking about a cell membrane. So this area up top is outside of the cell, and below it is inside of the cell. And I just want you to watch quickly how simple diffusion happens across the membrane. Here's my area of high concentration, and the oxygen particles are moving through to this area of low concentration, and now it's equal. Okay. I think I can bring it back if I do this. Just watch it one more time. Again, I have high concentration up here, low concentration down here, and they are simply going to pass through the membrane in simple diffusion. Okay. So this is super useful for really small particles, things like oxygen, things like carbon dioxide. Okay. And this is possible because a cell membrane is permeable. Okay. This cell membrane that we saw right here allows things to pass through it. Whoops. It allows things to pass through it. Now, we can make this word a little bit more accurate by saying it is semi-permeable, which means it allows some things to pass through it. So, an example would be a tea bag, right? It allows the flavor of the tea to pass through to the water, but doesn't allow the leaves. It only allows some things to pass through it. Same with something like a shower drain. It allows the water and the soap to pass through, but it like catches like your hair and any other things that need to stay in the actual shower, right? So just some things. This word is super useful when we talk about cell membranes because they only allow some things to pass through it. Cell membranes are semi-permeable. Okay, cool. Why is it useful to have a semi-permeable membrane? It allows necessary molecules to enter the cell. And this is mostly small molecules, things like oxygen and carbon dioxide. Now, sometimes the thing that's passing through the membrane is water. And when that's the case, we call it osmosis. So here's another example. This was Diana's example. In the beginning, the water is like separate from the oatmeal. Over time, it absorbs into the oatmeal. Now, if Diana had added something like salt or sugar to the water, it would not have passed into the oatmeal, right? It would sort of be left on the outside. So just the water passing into the oatmeal, diffusing through the membrane. Anytime we have that going on, we call it osmosis, okay? It's another example of simple diffusion. It just means that we're talking about water. All right. Now sometimes the molecule, like these little green guys, are just too big to pass through in simple diffusion. And so we call it facilitated diffusion, because something like a protein will pretty much just open a door in the cell membrane. And really, when you think about facilitated diffusion, it's still a high concentration moving to a low concentration. It's just that we needed to open up a space in the membrane to let it pass through. So when you think facilitated diffusion, you can think walking through a door. It's that simple. Okay, simple diffusion, osmosis, facilitated diffusion. These are awesome because they require no energy. You don't need any energy. You can be as sleepy as this sleepy baby. Anything that has no energy, we call it passive transport. And we can break these down. Passive means no action, right? We're not doing anything. And then transport means you're moving something. So this is how things move without putting any energy in. All right. Now we know that in passive transport, things move from high concentration to low concentration. The question is, can they move from low concentration to high concentration? Is it possible? Yeah, it is. And we call it active transport. So in this example, we have our cell membrane, we have our protein, and this thing that's low concentration is actually moving through to an area of high concentration. And the reason it can do that is because we add energy. This is like, if I break down this term, active transport, active means that it involves an action, right? And transport, again, just means that we're moving something. So the action in this case is the energy. And I like to think of this kid climbing up the wall. Maybe some of your siblings are acting like this right now. This kid has a lot of energy. He's going in a direction that is not normal, straight up a wall. And he can do that because he has energy. Okay. All right. So just a summary here on active transport. It moves in the opposite direction. It moves from low concentration to high concentration. This can be useful for things like glucose. Oops. So a quick summary here on active transport, it's the opposite. It moves from low concentration to high concentration. And it requires energy to do so. One example of this would be like if your cell is using glucose to do cellular respiration, it needs more glucose. So it can still be adding glucose. You could have plenty of glucose, but it could just be like getting more and more and more. And it would take energy to do that. When I imagine active transport, I imagine like pushing your way into a crowded subway, right? You can do it, you can get in there, but it takes energy. You got to like push your way through. So when you think of active transport, think about like pushing your way into a crowded space. All right, so again, all of these examples that we talked about today, we can divide them into two categories. Passive transport means no energy. Active transport means it requires energy. That's really the only difference. Passive transport means that we go from high to low. This is the natural way that things just spread out. Whereas active transport, this is the opposite. This is like pushing your way into some place that's already crowded. Active transport requires energy and it goes in the opposite direction. Active transport is just active transport. There's not like a bunch of other terms for it. We're just going to always call it active transport. Passive transport, this could be simple diffusion. It could be facilitated diffusion, where we have that channel, that door that the things walk through, or it could be osmosis when we're talking about water. That's like the big summary of the types of diffusion that you guys showed. A lot of different people showed really good examples. And I just wanted to sort of put some more vocabulary terms to it. So today for your activity, I want you to just think about these keywords: passive, active, transport, facilitate, and membrane, to start thinking about, if I saw these questions like in a Regents or something like that, how could I use the terms, the words, to help me understand what's happening? Okay. So when you go into your Google document, you can get that thing started. This is, again, just sort of a review. For some of you, it'll be sort of going beyond. For some, it'll be just kind of reviewing what we already learned. I hope you guys have an awesome spring break. Talk to your advisors, let them know what you're doing. If you end up doing something cool, let us know. We want to find out, like, what are you guys up to during spring break? I'll share a little bit about what I'm up to. I hope you guys have a great time. I hope your families are staying safe. If you need anything at all, please let us know. We love you a lot, and we miss you a lot. And don't worry, I'll keep sending good cat and baby videos, okay? All right, y'all. Bye-bye.